Unstimulated, neurons maintain a constant electrical difference, or potential, across their cell membranes. This potential, called resting potential, is always negative inside the cell and ranges from -40 to -90 millivolts. If a neuron is stimulated, the negative potential inside the neuron can be made either more or less negative depending on the stimulus. If potential is made sufficiently less negative, it reaches a level called threshold, and an action potential is triggered. During the action potential, the neuron suddenly becomes 20 to 50 millivolts positive inside. Action potentials last a few milliseconds before the cell restores its negative resting potential. The cell membrane of a neuron encloses cytoplasm with various ions dissolved in it. The neuron itself is immersed in a salt solution, the extracellular fluid. The ions of the cytoplasm consist mainly of positively charged potassium ions and large negatively charged organic molecules, such as proteins. Outside the cell, the extracellular fluid contains mostly positively charged sodium ions and negatively charged chloride ions. Since charged particles cannot pass through the lipids that make up cell membranes, they must travel through channel proteins that extend through the membrane. In an unstimulated neuron, only potassium ions can cross the membrane, traveling through specific proteins called potassium channels. Although sodium channels are also present, in unstimulated neurons, they remain closed. Since only potassium ions can cross the membrane, and potassium ions are more concentrated inside the cell, they diffuse out of the cell, leaving the large negatively charged organic ions behind. As more and more positively charged potassium ions leave, the inside of the cell becomes increasingly negative. But since opposite charges attract, as potassium ions diffuse out, an electrical force develops that tends to pull them back inside. At some point, the diffusion of potassium ions out of the neuron due to concentration differences is balanced by the electrical attraction tending to pull them back inside. This is the point at which neurons reach resting potential. Reaching resting potential in this way does not require significant changes in the potassium concentration inside or outside the cell. Only about 1/10,000th of the potassium ions initially inside a neuron must leave to create a resting potential of -60 millivolts. But it is action potentials, not resting potentials, that carry information through a nervous system.